Hello, welcome back. I'm Shivaji and you are learning linked list in this section. We have started writing the implementation of singly linked list. Now in this tutorial, I'm going to show you how we can implement insert at tail operation. In this operation, a dynamically created new node will be added at the end of the linked list. We often call this as insert at tail or append operation. Now, when you call the insert at tail, there can be either of two cases. The linked list is empty or there are already nodes in the linked list. That means it's not empty. We can check if the linked list is empty or not just by checking null in either of head or tail or 0 in node count. If the linked list is indeed empty and insert at tail function has been called, then we just need to copy the address of this new node to both the head and tail, as this is going to be the first as well as the last node in this situation. As you can see this happening in the animation. The address of the newly created node is 300 and the integer content of the node is 200. We'll always assign null to the next pointer field of the new node, as this will be the last node in the list. Now the address 300 is copied to head and then tail. So both the head and tail are now pointing to this new node. And we are done handling the case when the linked list is empty. We indeed added a new node in the list. Now let us consider the situation when the linked list is not empty. We consider the address of the new node as 900 and the integer content as 40. In this case, when the linked list is not empty and we need to insert a new node at the tail, that is as the last node of the list, we'll copy the address of the new node, in this case 900, to the next pointer of the current last node, that is pointed now by tail. And then we will update the tail pointer so that the tail pointer points to this new node. That is, this 900 will be copied to tail so that the tail will now point to this new node. And we are done. You can see that the new node with address 900 and content 40 is inserted at the end of the list. Now let us go ahead and write the code for this operation by considering these situations. Okay, now you're all set to write this function insert at tail. The function receives two parameters. The first one is a pointer to the linked list object, and that's list ptr, as you can see there at line number 61. And the second one is an integer data that we are going to put into a dynamically created node that we are going to add as the last node of the linked list using this function. So the function is going to add a new node as the last node of the linked list. Now, the first thing first, we need to create the node dynamically there. I'll be using the malloc function call for this purpose. So here you go. Now we know that if the malloc function successfully allocates the memory, it returns the base address. So we are keeping the address of the newly created node by malloc into a node pointer, that is new node ptr, at line number 62. In an exceptional situation, malloc may fail, and in that case, it returns null. So we are checking if the new node ptr is null or not. If that is indeed null, then we are just printing a message there at line 64, and we are just returning from this function. Otherwise, if the node has been created successfully, then we are just configuring the node. At line number 67 and 68, you can see that we are assigning the data that we receive as a parameter into the data field of the newly created node object. And the next pointer field of the new node object is assigned with null, because this is going to be the last node, so the next pointer field has to be null. Now we need to check if the linked list is empty or not, and we can just do that by checking the head pointer. If the head is null, then the linked list is empty, or you can check the tail either. If the tail is null also, then also the linked list is empty. And I'll be checking the node count. I think you remember that. The node count is a variable that we have declared there in the linked list object, and that's actually going to give us the number of nodes at any point. So this is the node count. I think you remember this. And we have initialized this node count as 0. So if the node count is 0, then obviously the linked list is empty. So I'll be using that node count. So here is the case. So if the node count is 0, then we are just assigning the address of the new node object in both head and tail. You can see that new node ptr is the address of the new node object that we have created dynamically in this function, and we have configured that node. So that address of the new node is assigned to both head and tail at line number 73 and 74. So if the node count is 0, we are assigning the address of new node to both head and tail, so that head and tail are both now pointing to this new node object. Okay, we are done handling the case when the linked list is empty. Now let us consider the other situation when the linked list is not empty. So in the else part, actually we'll be adding the address of this new node to the next pointer field of the last node, so that the current last node is going to point to this new node, and this new node becomes the last node, right? So the last node could be accessed by using the tail pointer, because the tail pointer always points to the last node, and the tail pointer is there in the list object, and we can use the list ptr to access the tail. So line number 78, list ptr arrow tail gives us the tail pointer, and that arrow next, actually the next of the last node, current last node, where we are assigning the new node ptr. So after line number 78, the current last node is actually pointing to this node, this new node that we have created at line 62 at the very beginning of this function. And the next thing is that we need to update the tail pointer, because the new node that you have just added is going to become the last node, and tail is going to point to this new node. So at line number 79, we are updating the tail, and the tail is right now pointing to this newly added last node. So that's it. And after all, after adding a new node, we need to increment the node counter by 1, and that we are doing at line number 81. So list ptr arrow node count plus plus, that will increase the node count by 1. So that's how I have added the new node, a dynamically created node, at the end of the linked list. And the algorithm is straightforward. First, create the node, check whether the node was created successfully or not. If not successful, exit. Otherwise, if the node has been created successfully, configure it. Add the data in the data field of the node, assign null to the next field, and then check if the linked list is empty. If the linked list is empty, this is the first node, this is the last node. So both head and tail are going to point to this node. Otherwise, if the linked list is not empty, this is going to be your last node. So the current last node is going to point to this newly created node, and the tail pointer has to be updated so that the tail pointer points to this node. So that's it. And in the next tutorial, I'm going to develop the algorithm insert at head. That's going to add a new node as the first node of the linked list. That's going to be just this, almost the same algorithm that we did here. Here we are actually adding a new node at the end of the linked list, and there at insert at head, it's going to be as the first node of the linked list. So in that case, we need to update the head pointer. Here we are updating the tail pointer, there will be updating the head pointer. Only this case is going to be different, and the rest of the thing are going to remain same. So I'd like to provide a task here. So can you just go ahead and write that insert at head operation by yourself? Just try it. Otherwise, we'll be writing that in the next tutorial, obviously. So join me in the next tutorial where we'll be developing that insert at head. Thank you very much.